All right, ladies and gentlemen, this is your last day of notes before our final quiz. So congrats for making it this far. I appreciate all the work you guys have put in. Really means a lot to me, so thank you for that. Okay, so today we're talking parabolas. This is, so far as I know, almost all review from Math 3. So we're going to jump in. Um, Parabolas, of course, either open up or down, or they open left or right, and it depends on which term is being squared. So you see right here, if it's opening up or down, um, the x minus h is going to be squared. If it's opening left or right, the y minus k is going to be squared. One thing to note when we're in standard form like this, the squared portion is always going to be by itself coming first, okay? On the right side, we have our linear term. Remember, we only have one squared term with parabolas, and the coefficient for the linear term is going to be 4p. So that's going to be, um, if there's a coefficient for y other than 1, we want to get that coefficient for 1. Same thing with x down here. Get that coefficient to be 1 by factoring out, and that'll help us to find what that 4p is going to be. So we'll jump in with an example of a vertically opening and a horizontally opening parabola. Y minus k squared comes first. That means this is my 4p value. And if that value is positive, we open in the positive direction. If it's negative, in the negative direction. So y squared indicates this is going to open either left or right, and 4p is positive, so we're going to be opening to the right. Vertex is hk, so that's going to be negative 1, 2. Let's go ahead and plot that. The focus is going to be inside of your parabola. So if we open to the right, the focus will be to the right of your vertex. What's the distance? It's going to be p units from our center. Okay, so the focus is going to be, let's see, 4p equals 12. P is going to equal 3. So I'm going to be 1, 2, 3 units inside. So there's a star that represents my focus. So we can go ahead and sketch. And the last piece, oh, I should write the coordinates there. The focus is going to be negative 1, 2 was the vertex. Let me come back and clean this up. I said center. I meant to say vertex before. There is no center. First mistake. Okay, for those still paying attention. So P equals 3. 3 units to the right, which means I will be at negative 1 plus 3, which is 2, comma 2. Directrix, that's going to be to the left. If the focus was to the right, directrix is going to be to the left. So how many units until I hit the directrix? Well, it's going to be P units. So 3 units left. So we'll go 1, 2, 3. And it's not a point, it's going to be a line, either a vertical or a horizontal line. If we open left or right, it's going to be a vertical line, the opposite direction. So my directrix is going to be this dotted line here. It's going to be an x equals or a y equals. This one would be x equals negative 4. Okay. I didn't ask you to find it, but we've talked about axis of symmetry. Let me draw that in. Here's my axis of symmetry. That's going to run perpendicular to your focus. I'm sorry, perpendicular to your directrix. Okay. So again, this distance here is a distance of P. This distance here is also a distance of P. Okay, easy enough. Let's do this one. Hopefully this one's a little cleaner. Okay, squared term by itself on the left. That means here is my 4p. It's 12 again. So vertex, 4, negative 3. Sketch it. Focus, let's see. P is going to equal 3, right? 4p is 12. Divide both sides by 4. We get p equals 3. So I'll be, let's see, this is an x squared, so it's going to open either up or down. 4p is positive, so we're going to open up. The focus is going to be p units, or in other words, 3 units up, because I want to be inside the parabola. And that's going to be at 4, 0. Right? We add p units to this coordinate. And my directrix is going to be 3 units down from the vertex. And that's going to be a y equals equation. And it's 3 units lower than the y value of my vertex. So it should be -6. And it is. Okay, so not bad. Tricky part, of course, comes from when I have completing the square, right? So I'm in general form here. General form. I need to go to standard form. So let's think about it. I want my perfect square on the left side. So y is squared. I want everything dealing with y on the left side. So y squared plus 6y. And then I want to get this 8x and the 25 over to the other side by subtraction. So this is going to equal -8x minus 25. Let's complete that square. Put a blank over here to balance. Half of 6 is 3. Squared is 9. No parentheses in front, so I'm just adding that value of 9. This gets me y plus 3 squared equals -8x. -25 plus 9 is -16. Remember, I want a 4p value, and I want my coefficient for this linear term to be 1. So I need to factor out this coefficient. So I get y plus 3 squared equals, factor out the -8, and we're left with x plus 2. Okay, so that's how we can get into standard form for a parabola. So we have a, keep saying center, we have a vertex at -2, -3. What direction am I opening? This is a y squared, which means I'm going to open left or right. -8 tells me I'm opening in the negative direction, so this will open left. Let's see, 4p equals -8, p equals -2. How do you move a negative number? Well, we just take the absolute value. I'm going to move 2 units. This negative right there for -2 just represents your opening in the negative direction. We already knew that because I knew I have to move inside the parabola, which would be left, which is negative direction. So I'm going to move 2 units into the parabola. So that's a focus value of -4, -3. The directrix is going to be, let's see, 2 units to the right. So again, it's not a point. I just use that so that I can sketch my line. It's going to be vertical, and that's going to be a x equals 0. Not bad. Okay. Last completing the square example. So again, this is a y squared. Everything with y is going to stay over here. We'll move everything else to the other side. Complete the square, balance. Half of -4 is -2. Square it gets me 4. I need to add 4. Y minus 2 quantity squared equals, let's factor out the 4 and gets me x plus 1. Vertex -1, 2. Here is my 4p value. 4p equals 4 equals 1. Which way am I opening? Left or right? 4p is positive, so I open right. So the focus will be p units, the right, inside the parabola. So that's a value of 0, 2. Directrix from the vertex, move 1 unit left, draw a vertical line through it, x equals -2. So hopefully these get quicker and quicker for you. Okay, now from the given information, we want to write the standard form. So first thing is figure out what's going to be my squared variable, x or y. Well, I'm opening to the right, which means y is going to be squared. So it's going to be y minus k squared equals 4p x minus h. I have a vertex here of -2, 5, which tells me my h and k. So I'm going to have y minus 5 squared equals 4p x plus 2. I need to find that p value, right? 4p should just be a coefficient. It shouldn't have a variable involved. Well, I have an x and a y that I can plug in, and then we can solve for p, or for 4p. So x is 2, y is 3. 3 minus 5 squared equals 4p 2 plus 2. -2 squared gets me 4 equals 4p times 4, which is 16p. A lot of people rush here and say that p is going to equal 4. Not true. Divide by 16, divide by 16. I get p equals 1/4. Okay, so I need to plug 1/4 in for that p value. So 4p is 4 times 1/4, which is 1. So standard form, y minus 5 squared equals 1 times x plus 2. Okay, that's it. We're done. Feel free to log on for some live notes and check out the rest of the stuff you need to do for assignment and exit slip. Thanks, guys. You rock.